Virtual Academy, Unit 5, Combine Inequalities or Compound Inequalities, right? Or Inequality. For this problem 1, 2, and 3, these problems, right? Let's start with number 1. Remember, combined inequalities or compound inequalities are quite the same. b greater than -1. We have to graph this on the number line. Because b cannot be equal to -1, equal sign is missing, I will use an empty circle, right? b has to be greater than that. It means it goes all the way to positive infinity. This is negative infinity here. Next inequality, b less than or equal to 3. Okay, because it could be equal to 3. It could and it should be a full circle here, right? And we'll go all the way to negative infinity because b will be anything that is less than or equal to 3. And now, because you have a conjunction here, right, because it says your number b, or you're looking for the number b's with this property of being greater than -1 and less than 3, you need to find the intersection of these two intervals, right, which will have these two endpoints, -1 and 3, excluding -1 and including 3, and will be all the numbers between those two, right? And this is how you graph problem number 1. Let's pull that. Alright, next problem. Y less than or equal to -4 or y greater than 0. This is a disjunction here, okay? But first of all, you need to solve each one of them. You need to graph each one of these inequalities, right? Y less than or equal to -4. It can be equal, right? But also has to be less than everything from -4 down to the negative infinity. The other inequality, y greater than 0. Y has to be greater than 0. It cannot be 0, so I'm going to use an empty circle here, or an empty dot, right? And I will go to the right because it has to be all the numbers, or any number that's greater than 0, all the way to the positive infinity. Now, because we have a disjunction here, that implies that, I can have any number that will satisfy either one of these two inequalities. I can have a number that's either less than or equal to -4 or greater than 0. And for that, your solution set will be the union of these two intervals. So you'll have everything from both. Okay? That's the answer for number 2. Let's try number 3. Your number 3 problem here is giving you only one inequality, as one expression. 2 greater than or equal to q, which is greater than or equal to -5. Now I would like to write it backwards. Okay, so I will flip everything, the whole expression, and I'm going to write it backwards. I'm going to put the smallest number first, -5, which should be less than my q, which should be less than 2. You see? When you flip it, make sure your inequality sign faces your numbers with the same side, right? And now I'm looking for my endpoints. -5. -5 on the number line is going to be here, and I'm using a full circle here because I have the equal sign. My q could be equal to -5. Okay? And then the other endpoint would be 2, also a full dot because it can be equal to my 2. And q has to be between them, right? And this is your graph. Everything between -5 and 2, or you may say q will be part of this interval, -5 to -2, and using brackets, because that will tell you that you're including -5 and -2. For number 2 here, I can write that as what? Y would be an element of the interval from -infinity to -4. The union of this interval with the other interval, which will be all the numbers from 0, and as you can see, I'm using a round parenthesis here that will exclude 0 from my solution set, to positive infinity. Okay? For number 1, b will be an element of the interval from -1 to 3, bracket for 3 because 3 will be part of my solution set. Okay? Any questions? Let's do another problem. Problem number 4, 2x plus 4 less than or equal to 6 or x greater than or equal to 2x minus 4. You take one at a time. 2x plus 4 less than or equal to 6. To solve, take away 4 from both sides. Okay, 2x less than or equal to 2. Next step, divide by 2. If I'm going too fast, pause me, right? Try to understand what I'm doing. X less than or equal to 1. Got it? Okay, if you want to graph it, less than or equal, full dot, all the way to the negative infinity, all the numbers that are less than or equal to 1. Next one, x greater than or equal to 2x minus 4. To solve it, you will add 4 to both sides, right? And you will take x away from both sides. You don't have my x's on the right, because I have 2x on the right and 1x on the left. The greater coefficient is right here. Okay? Subtracting and adding. I have 4, x minus x, nothing. Inequality sign does not change. 2x minus x is x, minus 4 plus 4, nothing. We can write it backwards. X less than or equal to 4. Okay? Let's graph this one also. 4, full dot, full circle, because it can be 4, and will be everything down to the negative infinity, right? All the numbers that are less than 4. Now, because this is a disjunction here, your problem is telling you that it could be any x that will satisfy any one of these conditions. The answer will be all the numbers from -4 to the negative infinity, including 4. Or you may say your x will be part of the interval negative infinity, 4, including 4. Okay? Any questions? Send me a message and I will be glad to answer. Problem number 5, d minus 3 less than or equal to 6d plus 12 less than 2d plus 32. So we have two inequalities here. First of them will be d minus 3 less than 6d plus 12. The other one is going to be 6d plus 12 less than 2d plus 32. And what do we have in here? Is this a disjunction or a conjunction? It's going to be a conjunction, right? It will be and. Okay, so I'm looking for a number d that will satisfy both of this relation. First thing, let's solve the left side, right? 6d is greater than 1d. I will take d away from both sides and use the same color. And I will take 12 away from both sides. So my numbers will be on the left, my variables on the right. D minus d nothing, negative 3 minus 12, negative 15, less than 5d. 12 minus 12 cancels out, divide by 5. Negative 3 less than d, right? Because 5 divided by 5 is 1. Or you may say d greater than negative 3. Okay? If you want to graph it, negative 3, empty circle, all the way to the positive infinity. Next problem, 6d plus 12. I will keep my d in the middle, right? I will take 2d away from both sides. And I'm going to subtract 12 from both sides. Okay, 6d minus 2d, 4d. Is there such a 4d out there? I don't know, TV set, I know 3d, but 4d maybe the future, right? Holographic one. Less than 2d minus 2d, 0. 32 minus 12 will be 20. Okay, last step here, divide by 4. I need to find d. D should be less than 5. Okay, to graph this one on the number line, you will plot your 5, empty circle, and it has to be less than that. So it'll be everything down to the negative infinity. All the numbers from 5, excluding 5, to negative infinity. And your solution set, because it has to be both conditions here, your numbers should satisfy both requirements, right? Less than 5, greater than negative 3. Your answer will be everything in this interval here between negative 3 and 5, all the numbers. Or you may say D should be part of the interval negative 3 to 5, excluding your endpoints, right? Make sense? Let's try another one. Okay, number 6. Solve and graph, right? I got 4 times g minus 3 plus 2 less than 6. First step, distribute that 4 to everything inside the parentheses. 4 times g is going to be 4g. 4 times negative 3 will be negative 12 plus 2 less than 6. Combining your like terms, minus 12 plus 2 is going to be minus 10 less than 6. Next step, add 10 to both sides, right? 4g minus 10 plus 10 is 0 less than 16. Divide by 4. Your g should be less than 4. Okay, you should graph it. 4 is here, there's no equal sign. Okay, that's negative infinity, that's positive infinity directions. Less than all the numbers to the negative infinity. Okay, let's get the other equation. 7g greater than 3 times 2g minus 1. First thing, multiply that 3 to everything inside that parenthesis on the right side. 7g greater than 3 times 2g, 6g. 3 times 1, 3 minus 3. Okay, take away 6g from both sides because I want to have my g on the left. 7g minus 6g will be just g greater than 6g minus 6g, nothing, negative 3. And OMG, we are done. Let's graph it. G greater than negative 3. Okay, empty circle all the way to positive infinity. It has to be greater than that. Your solution set will be the overlapping of the two intervals here, because your G has to be a number that's between 4 and negative 3. Or you may say G is part of the interval negative 3 to 4. Open ends, right? Make sense? You should go ahead and do number 7. Okay, let's try another one. Graph the solution of each compound inequality. This is a very simple problem. I'm going to do number 1. B greater than 3 or B less than or equal to 0. First of all, B greater than 3. Where is 3? 1, 2, 3. 3 is right here. And you have an empty circle. Greater than that goes all the way to the positive infinity direction. That's negative infinity. B less than 0, less than or equal to 0. Okay, it has to be full dot, goes all the way to the negative infinity. Okay, because you have a disjunction, either one will be fine. Your solution set will be the union of these two intervals. Okay, you can write B is an element of the union of the interval negative infinity to 0 and 3 to positive infinity. Alright, go ahead, do number 2 on your own. Write a compound inequality for each solution set. Now this is, working backwards. If number 7, hopefully you can see that, your solution set has an open, empty circle here and the full 1 over there, right? So for this part, you have what? Let's say x should be less than negative 2. Okay, the other interval is x greater than or equal, I have a full dot, to what? To 1. And I will have or, because both intervals are part of my solution set, or they're making my solution set. And that's it. Number 8. As you notice, your solution set is between those two numbers. That's an open and that's a closed dot. Okay? So you can start with any one of your endpoints. This is what? Negative 3. And you may say first thing, negative 3 should be less than my, I don't know, let's say m, which should be less than or equal to what number do we have there? 3. Okay? And this is it. This is a conjunction. You need to have both conditions satisfied. Your number should be greater than negative 3, but no greater than 3. Okay? How about this one? Number, which one? 11? Let's do 11. 2x minus 1 less than negative 1, or 2x minus 1 greater than 1. Okay? So we have the first one, 2x minus 1 less than negative 1. To solve, you add 1 to both sides. You have what? 2x less than minus 1 plus 1 is 0. Obviously your x is what? What number times 2 is 0? 0, right? X should be less than 0. Less than 0, open circle, open dot, empty circle, whichever way it goes. Right? Negative infinity, and that's your first one. The second one, 2x minus 1 greater than 1. You add 1 to both sides. So you're going to add 1 to both sides, right? And you have 2x on the left, minus 1 plus 1 cancels out, greater than 2. Next step, divide by 2. 2 divided by 2 is 1, 1x greater than 1. Okay, and this is your second inequality here. To graph it, you're looking for 1. Okay, 1 on the number line is here. Empty circle, because it cannot be equal, only greater, right? And we'll go all the way into the positive direction, positive infinity direction. Okay. And now, because you have a disjunction here that says or, I need to use everything from both inequalities, right? All the solutions, the solution set of both, the union of that. And as you notice, the only thing is missing here will be the interval from 0 to 1. And you can say that actually x here will be part of all the real numbers without the interval from 0 to 1. Okay? That's one way, or you may put it as the union of the two intervals. I'm just showing you guys other ways to write this. You may not have it this year, but if you move on into college, will definitely be there, or in the more advanced classes into the next years. Okay? One more, and this is it for today. Problem number 12. 0 greater than or equal to negative 1 minus z, and negative 3 less than the negative 2z minus 1. We're going to start with the first one, right? 0 greater than or equal to negative 1 minus z. Okay, how should we solve this one? Well, you know what? I'm going to add z to both sides. That's probably the best way to go. In one step, you're done, because 0 plus z is going to be z greater than or equal to negative 1 minus z plus z. Nothing, and you're done. You solved it, right? Negative 1 on the number line is here. You will use a full circle because it can be equal to, and because it has to be greater than negative 1, we'll go all the way into the positive direction toward the positive infinity. The other one, negative 3 less than negative 2z minus 1. Okay, I can do the same thing here by adding 2z. I like to have my variable positive. I will add 2z I'm going to add 3 such that my 3 will move from the left side. I hope you guys understand what I'm doing here, right? I'm just putting 2 steps in one. Adding 2z to both sides, adding 3. 2z on the left, minus 3 plus 3 will be 0, less than or equal to negative 2z plus 2z, nothing, minus 1 plus 3 will be 2. Divide everything by 2 to find your z, right? Z less than 1. And that's your second inequality. Plotted, 1 is here, less than, because there is no equal sign, right, will be an empty circle, and we'll go all the way down to negative infinity. Because you have a conjunction, you're looking for the interval, the intersection of the two intervals here, right? Which will be whatever they share in common, whatever they overlap. You see right here, they're overlapping, and that's your answer here, right? This is your graph, or you may say z would be an element or a number of the interval negative 1 to 1 excluding 1. Okay, I hope you got it. We'll do more. Thank you very much. Let me know if you have any questions. Bye bye.